Mr. Chairman, we're live.
Well, thanks, Molly. We'll wait a couple of moments for the Zoom attendees to be admitted to the meeting. Hey, good morning, everyone. This is Chauncey Goss, Chairman of the South Florida Water Management District's Governing Board. And today the Governing Board is pleased to present our Lunch and Learn on the maintenance of the world's largest water management system. Vice Chair Wagner's not going to be able to join us today. I'm going to do a quick poll of our board members. Board members, please confirm that you're on when I call your name. Mr. Bergeron.
Here.
Great. Mr. Butler.
Good morning, Mr. Chair.
Good morning. Mr. Hurley. He may have some travel issues. Mr. Martinez.
I'm here, Mr. Chairman.
Thank you. Colonel Roman.
Good morning, Mr. Chair.
How you doing, Mr. Spotswood?
He may
Mr.
also have
Steinle.
travel issues, Chairman.
Thank you. And Mr. Steinle? I think he was going to join, but he might be here a little bit later. And I'm on. As a reminder, today's Lunch and Learn is informative. We're not going to be taking any actions or votes. Governing board members, if you have specific questions, you can ask them during the presentation. However, we're going to hold off on discussion until after the public comment. And after the presentation, we will take public comment. Members of the public who wish to address the board can use the raise your hand feature on Zoom. And if you're using a phone and you'd like to comment, please press *9 to raise your hand and *6 to mute and unmute. Before we start, I'd like to remind everyone that Lunch and Learn sessions have a 1 o'clock hard stop. So now we'll go over to our Executive Director, Mr. Bartlett. Drew?
Thank you, Mr. Chair. So we thought this would be a very good time frame to basically do an education of the board and the public on what it means and what it takes to maintain one of the world's largest water management systems. We just submitted last week our preliminary budget for next year. And whenever you look at the Water Management District budget for South Florida Water Management District, what you see is a major investment in maintenance and operations of our infrastructure. It is the lion's share of our budget, generally speaking. And so we wanted to do basically a lunch and learn to go through all the details and what it really means to maintain and operate our water management district flood control system. And so you really can't talk about that without having a little bit of history lesson on why we are what we are at this time. And that all begins with the devastating floods in the 20s and the 40s, which basically spawned a federal authorization to construct this flood control system that we operate today. It's the Central and South Florida Flood Control System. And you see the map there on the left. That is the original map. It looks like an historic map because it is. This infrastructure was built in the 50s and 60s in a decade and a half to serve the communities of South Florida. And it does a fantastic job at flood control. The hurricane we had, the rains we had with Hurricane Irma were the same that were deposited during the 40s hurricanes, and you did not have the widespread flooding that you did at that time. So it protects homes, it protects businesses, it protects households and communities, so it does a fantastic job. But as we have learned, it also has consequences. While it underpins the economy of the state, there's also economic impacts when it comes to basically dumping a lot of freshwater resources, valuable freshwater resources into our estuaries and on top of the Everglades and Lake Okeechobee. So you end up with wildlife impacts, you end up with economic impacts. In the wet season, too much water is going to our estuaries, impacting those ecosystems. In the dry season, you often have too little. And when you're talking about Florida Bay, it was always too little because it was cut off from the Everglades with Tamiami Trail. So there are consequences that we are addressing today, which get into our infrastructure. So this is the numbers for how much infrastructure we have. And when it comes to canal maintenance and levee maintenance, Rich Virgil and his team is going to go over what it takes to maintain those and the structures and the culverts and the pump stations, because we have a lot of that infrastructure. And when you're talking about the the 2,100 miles of canals and levees. If you string them together, that'll get you from here to Los Angeles. It is a monumental set of infrastructure maintained, and the maintenance on this is huge scale maintenance, which is why we wanted to have this. It's not like maintaining an appliance, right? This is massive infrastructure. And also, as we stand here today, we're adding new infrastructure year by year. Heck, next week we're going to cut the ribbon on even more infrastructure, right? And that's because of these unprecedented investments, right? We talked about the damage this system was doing to parts of our system and the economies of parts of our system. And that spawned the governor working with the legislature to really do some investments to retrofit this system. And as of this week, we're up to 82 projects and milestones completed to basically replumb South Florida to use water better. And what that looks like is, in pre-2019, you had these harmful discharges. You remember the discharges in 2018 going west of the Caloosahatchee Estuary, taking toxic freshwater algae, then interacting with red tide and causing an economic calamity on the West Coast. The same thing happened on the East Coast in 2016, the lost summers. And if you think about it, that's valuable fresh water. So you're dumping it out to sea, right? And the better thing to do with that is keep it in the system, protect the estuaries from those harmful discharges, and put it where it needs to be, which is what this past 7 years of investments has done. So you have better water going into Lake Okeechobee. You have reservoirs east and west of Lake Okeechobee trying to intercept those flows. And the C-44 to the east side has been online for a couple of years. It is absolutely doing that. This past wet season, we didn't let any water out of the C-44 into the estuary. It all was put into the reservoir. And then you have, of course, the signing this summer with Governor DeSantis and the Trump administration expediting the EAA reservoir so you can connect Lake Okeechobee to the Everglades, finish the uncorking of Tamiami Trail, and get it back down to Florida Bay. We're seeing some results in Florida Bay now, but with the EAA reservoir and the implementation of the Tamiami Trail, we are going to see big differences down there. And so retrofitting that whole flood control system means we're completing projects. And when we're completing projects, they're coming online and shifting to operations, right? And so we had the east and west reservoirs completed. And I've asked about the budget and the budgeting for those. For the east reservoir, it's $3 to $4 million a year. For the west reservoir, it's $4 to $5 million a year. So these are new projects coming online that we have to incorporate into our maintenance budget. That's the same with all the STAs we've been building around the system. South of the lake, the Restoration Strategies put 60,000 acres of STAs online, and if you add up all the STAs around Lake Okeechobee, you're up to over 100,000 acres of stormwater treatment areas, all to be operated and maintained. The list goes on. I mentioned we had 84, and so the last ribbon cutting we had was down for all the completion of Biscayne Bay coastal wetlands. That's more pump stations, more structures to maintain. So the amount of infrastructure we're maintaining is growing, and we are seeing the benefits. We will see the benefits for our economy. We'll see the benefits for our natural systems, and so it is absolutely worth it, but it has to be maintained. And so this is what basically this is the size of maintenance that we do, right? And Rich will go into more detail, but it's large pipes, it's large engines, it's massive gates. It's you're using machinery to do the maintenance. It is not your toolbox, right? This is big time maintenance that we have to do, and it's for the benefit of all the people. We have 9 million people in the South Florida Water Management District, 6 million along the East Coast, tons of people and businesses depending on this infrastructure, and so the maintenance becomes critically important. You have to layer on top of maintenance basically that we have different conditions too. So Rich will get into the capital program a little bit, which talks about, hey, this structure needs to be rebuilt, but it also needs to be adapted for all these changed conditions. The original flood control system was built to serve 2 million people, right? We got 9 million now and growing. So it is it is something that has to not only be maintained, but it has to be adapted over time. And you really can't talk about the infrastructure maintenance without also talking about land management, because a lot of our infrastructure basically interacts with the land and it's there for the purpose of the land. And so we have a lot, we will get into what it takes to maintain our 1,000,000 acres of land through fire, exotics control, all the different things we do to not only the hard infrastructure, but also the natural infrastructure that we have to maintain as well for the benefit of South Florida. So, and while I'm talking about this and talking about how it's a monumental effort that takes a lot of resources, I also have to point out that this district has also taken the initiative of making sure that we're lean when we're doing this. We're constantly innovating. We're constantly looking for ways to do more to be that impactful district to help South Florida, but not increase our taxes, right? To keep within our budgets. And so over time, you've seen we've actually had a reduction in full-time employees. We've had a reduction in our operating budget while still accomplishing what we're accomplishing with permit reviews, all the new infrastructure we have coming online, land management, and it goes without saying that we're managing a lot more contractual dollars now than we were before 10 years ago. And so we're doing more with less, but it's still a lot to do, right? So what we're going to do is I'm going to turn it over to Rich so he can go into the details, and he's going to go into a lot of details, and that is on purpose, because to really get an understanding and a feel for what it takes to maintain this system, I think we have to do a dive, right? We have to dive into this and really understand what it takes. So with that, I'm going to turn it over to Rich and Rich Virgil to take you through the rest of the presentation.
Good afternoon. I'm Rich Virgil. I'm the Division Director for Field Operations. I can attest to the fact that the system has significantly grown in my 30-year tenure here at the Water Management District. I'm going to break the presentation down into multiple different facets, from the levees and berms to the canals to the structures, the pumping stations, communications, SDAs, and reservoirs, and kind of give you a flavor for everything that we have to do to maintain this system. I'm going to start with the fact that we have 8 field stations that manage the field, all of this work, and they're located from St. Cloud to Homestead. Close to 300 staff that manage all of the system for us. So I'm going to start with the levees here. So the levees and berms, we got 2,130 miles of levees and berms. They're very important to the system. As you can see from this photo, this is a nice aerial shot from our S6 pump station, which is the inflow pump to STA2. At that corner, you can see the levees separating water conservation areas from each other. You can see a levee separating STA2 from the conservation areas. But levees also separate the water conservation areas from coastal communities in Palm Beach, Broward, and Dade. And levees also separate and segregate drainage basins within the EAA and other locations. So, what do we do to maintain our levees? Well, we want to prevent unwanted vegetation. And how do we do that? Well, we do it by, one of our big tools is mowing. And we mow in order to prevent woody vegetation from growing on the levees. Root systems can cause seepage. Root systems can cause unstable conditions within a levee. Uprooted trees and vegetation can cause erosion problems. And trees can even fall into canals. So we do 4 mowing cycles per year. There are 2 types of mowing that we do: flat mowing and slope mowing. Flat mowing is open right-of-way mowing. Slope mowing is on side slopes that are in greater elevation than 2 to 1 in slope. Costs vary significantly based on location. In more urbanized conditions in the south, where contractors have to mobilize and demobilize and open gates and cross roads and bridges and stuff to complete their work, the cost is higher. When you get into the Okeechobee area or the St. Cloud area where you have miles of open levee and canal, the cost is a lot less because they can get a lot more done in a day. There's also an increased cost for slope mowing. Slope mowing can range from $180 to $280 per acre. It's again influenced by the urbanization effect, but it's more costly than flat mowing because you have to have specialized equipment to complete that, such as the photo here where district staff is using the articulated arm boom mower to mow the side slope. In saying that we contract out mowing, we also do mowing in-house as the Fort Lauderdale team takes care of the East Coast Protective Levee throughout Broward and Miami-Dade counties. We also maintain the levees through grading to prevent erosion. One of our main goals is to prevent the degradation of the crown elevation of the levee. So you want to do grading and control the water as it flows over rain from rain events and stuff so that it doesn't cause erosion to the levee. We also have to maintain all of our roads. You know, a lot of access is done from our levee roads and canal roads to get to all of our facilities for operation and maintenance as well as emergency response. Again, we do 4 grading cycles per year, and the contracts are isolated to just the West Palm and Clewiston areas because they have a lot more roads and levees to maintain because of all of the stormwater treatment areas in the area there. And then throughout the rest of the district, district staff maintain all the levees and roads. So you can see what we do to maintain that 2,100 miles of levees. Now we're going to move into the canals. And again, we have almost 2,200 miles of canal. That's the distance, more than the distance of I-95 from Miami to the Canadian border. You can see our dredge here that works up in the Okeechobee area. I'll provide more information on that later in the presentation. So what do we need to do for our canals? Well, we need to keep debris and vegetation out of the canals to prevent flooding. Vegetation and debris can cause blockages at structures, which can increase flooding risk. We need to keep the vegetation out in order to keep conveyance moving in the canals and keep them free of issues. It also allows us to do our inspections and move around within the system. And mechanically removing debris and vegetation from the system and the canals keeps it from settling out to the bottom, which then can flush through the structure at a later time during high flow events. So in Miami-Dade County, we do a lot of structure cleaning. We have a lot of debris in our canals because of the highly urbanized environment that these canals are in and they serve. This is our poster child for canal cleaning at structures. The S27 is cleaned twice a week, as well as several other of the coastal structures in Miami-Dade. Basically, keeping these clear keeps the structure open and the volumes flowing, but it also prevents all of this debris and vegetation from flowing downstream into the Biscayne Bay, where it can have issues with water quality. It can even negatively influence marine life. So here's some canal vegetation work that we do in BCB on the Miller Canal, as well as the Miami-Dade Homestead canals. They're very shallow in nature, and those shallow canals during the summer months rapidly grow submerged aquatic vegetation, and you can get a condition in this before picture where the canal actually looks like it's topped out with vegetation. So we go in and mechanically remove this with boats and trash trucks so that we can open it up for flow like it is in the after picture on the right. We also have to rehabilitate canal banks throughout the system. This picture is of the Okeechobee team rehabilitating the C40 canal after we did a dredging project here. But even in other cases, we get sloughing and degradation of the canal banks during high rain events, and we need to keep that debris and stuff from entering the canal, causing blockages. We want to keep these things open and clear. One of our other tools that we use is we work with our vegetation management section to work with contractors to remove vegetation and hazardous trees from the canal banks that can fall into the canal and cause issues with blockages. This is a picture right out here on the C51 canal where we've been working along the bottom edge of the canal to remove all the hazardous trees, the low hangers, the ones that overreach the canal. I'm going to run a little video here, I hope, of the process of removing these trees. So basically you have a barge mounted activity here because you can't get to the canal bank on the north side. The trees have to be removed and placed on a barge and then transported down to the canal to the offload section. The trees are then offloaded onto the bank, and then eventually they are placed into a chipping machine that shreds them up and chips them and then places them in the truck to be hauled off. So it's quite an operation, and this is just one of many locations throughout the district that we do this work each year. We also work with our veg management crew to hire contractors to do mechanical removal within the canals. This is work down on the C111 canal in Homestead. It's a much larger canal than the other canals in BCB and Miami and Homestead that we do our own work with our towboats. So we contract directly with a contractor that has the appropriate equipment to remove the hydrilla from the canal. Removing mechanically like this helps us reduce our dependency or our use of herbicides. Another tool is to use sterile carp. We introduce sterile carp to eat submerged aquatic vegetation from the canals. We stock the canals with these fish, not every year, but every other year or so. It's an effective way, a non-chemical way to control vegetation within the canals, to keep them all open and flowing. I spoke earlier, we have our dredging program up in the Okeechobee area. So this is crews from the Okeechobee Field Station. They're removing about 50 years worth of accumulated sediments within the C25, 24, and 23 canals. This is going to be critical to get these canals open and ready for the CERT projects that are going to start up there in this area so they can work more efficiently. So there's a whole process that goes into doing a dredge project. You don't just bring the dredge out and start digging. You have to be able to clear the existing spoil mound that was there when the canal was originally dug, clear all the vegetation. We open that up in order to get it ready to receive the dredge material. Then the dredge comes in behind the prep work and starts dredging and actually fills the containment area with the spoil coming out of the canal. At the end, the containment is encapsulated, it's graded, and it's sodded to a finished product. And then hopefully we don't have to come back here for many years. We also have a project culvert replacement program. So when these canals were originally dug by the Corps back in the 50s and 60s, project culverts were installed to drain floodwaters from the adjacent land into the canal. You don't want floodwaters from the adjacent property flowing over the canal banks, which would cause erosion. So you control the flow into the canal through a series of project culverts. There's over 620 project culverts within the system. This is a large replacement that I'm showing you here that was done by the Okeechobee Field Station of a 50-year-old culvert on the C41 canal. If you do not replace these periodically because they age out, they corrode, they rust, there's opportunity for them to collapse. That would damage the canal bank. It could damage a levee. So it's important that we have a program that addresses these culverts. So now you can see all the work that sort of goes into maintaining the canal system, right? We do vegetation management through mowing, and we do vegetation management through mechanical removal. We use carp. We do a lot of different ways to control and manage this almost 2,200 miles of canal. Next are the structures. So we have 935 water control structures in the system. It's a massive system. This is one of our largest structures on the Kissimmee River. This is our S65E structure in conjunction with the S65EX1. Flood flow through this structure combination is 37,000 cubic feet per second. So I'm going to get into some information on unique stuff and some different things that we do for structure maintenance. But keep in mind, structure maintenance is all about preventative maintenance. We do a preventative maintenance program on all of these structures. We have structure maintenance techs that do quarterly preventative maintenance. We have electricians that go out to do quarterly maintenance to make sure that all the power's working correctly, the gates are opening and closing, the emergency generators that are on site can operate and work, and all of that takes preventative maintenance just like it does to maintain your car. There's also SCADA maintenance that goes on for the operations control side of the house. So we do a lot of maintenance on these structures just for preventative maintenance. We try to spend 80% of our effort in maintenance and only 20% in reactive emergency repairs and follow-up. So here's a unique kind of maintenance that we have to do above and beyond preventative maintenance. We have manatee protection systems on a lot of structures throughout the district. The manatees screens, in this case, protect the manatee from being harmed going through a gate, or we prevent them from accessing sections of the water management system that are undesirable to have them in. So these screens, when the gates open, will accumulate debris and vegetation on them. They have to be cleaned so that water can flow through the structure. This large one is probably cleaned at least twice a year or as conditions warrant. This is a large mobilization and a lot of work to lift this gate out of the water. This is on a structure on the south side of Lake Okeechobee to shake it clean and then place it back into service. We've also installed some permanent systems on some of these structures so that we can be more reactive to the cleaning events and make it quicker and easier to do. We have manatee protection systems and electronic systems with bumpers on 36 gates and locks within the system. These bumpers have a life cycle of around 10 to 15 years, so they have to be changed out. Here's the field station working on this one. There's a bumper strip on each side of the gate. The cost per gate alone is in the excess of about $125,000 just for the bumpers, not including the electronic side of the house that all have to be maintained. So now I'm going to describe one of our big programs we have within the structure maintenance shop. We have our major gate overhaul program. We have a big facility in West Palm Beach where all the gates are sent to for major overhauls. So I'm going to step you through the process here quick. Step one, we got to dry the structure in, and that means placing large panels into the structure. We have to have a diver in the water to guide the panels into the water, make sure the sill is cleared so you get a good seal. The panels prevent water from moving through the structure when the gate is removed. Then everything has to be broke down and made ready for transport. Everything's transported then up to West Palm Beach. When it gets to West Palm Beach, it's further broken down, it's disassembled, it's cleaned and prepped. We then get into making any repairs to the gate, metal repairs, rust removal. Gate is completely sandblasted down. It's recoated and painted in our facility in West Palm Beach. One of the critical components of a gate is its wheels, and the wheels have to be refurbished or replaced during the major gate overhaul sequence. There's also a bunch of ancillary equipment associated with the gate, from pulleys to cables to framework. Some of the gates are hydraulically operated, some are electronically operated. So all of these components have to be gone through and refurbished. Like I said, not all of them are cable driven. Some of them are stem driven electric motors, and those electric gearboxes and motors have to be disassembled, seals replaced, bearings replaced, recoated, metal work done on them, and put back together. Once everything's completed, it's shipped back to the site and it is all reinstalled. Excuse me. The gates are overhauled on a frequency of about every 10 to 15 years. We do about 10 to 15 overhauls per year at a cost of around $46,000 per gate. this is a case here at S71 of an emergency repair that we did this past year. The S71 structure is in design for replacement, so we've kind of been putting off the major gate overhaul and waiting for the replacement of the structure to take place. But in the meantime, due to the acidic water in the north section of the system and long-term exposure, right? This structure's been in operation for decades. There's been degradation of the concrete. And you can see the gentleman's hand behind the rail, which is actually a short-circuiting path for the water to flow around the gate. Yep. So right there, so what we had to do is kind of do an in-field emergency gate overhaul. And we pulled the gate all apart, took it out, did a lot of work like I had described in the previous slides, but did it in the field. But then here on the right, you can see where we had to replace the concrete and shim this up and get this back so that when the rails were installed, they were flush to the concrete and no more short-circuiting of the water would occur around the gate. So as you can see, we do a lot of different work for the 935 water control structures in the system, from our preventative maintenance to manatee activities to the major gate overhaul program and everything in between. So now I'm going to move on to the pump stations. So in this next series of slides, I'm going to describe two processes. So as a pump station gets older and times itself out in service, it goes through different refurbishment cycles. So we're going to start with like a contractor refurbished pump station because of the scope and scale and magnitude of the refurbishment is a major refurbishment, to a mid-life minor refurbishment that the field station will execute by their own labor and use of contracts. This is the S9 complex down on the C11 canal in western Broward County. As you can see here, there's a separate automated trash rake system that is included, the fuel farm. We got our SCADA telemetry tower so it can be monitored and worked with back here in West Palm. We got our crew quarters. We got our main pump station, S9, that houses the three 960 CFS pumps. There's a new generator building here with new emergency generators. And then the S9 pump station that supplements the capacity of the S9 structure itself. But keep in mind, there's 98 pump stations in the system, over 300 pumps. These stations and all of them also have to go through preventative maintenance cycles as well. We have a monthly checklist that's done for all of them. And then electricians and come in to make sure everything's working properly, as well as our instrumentation and controls technicians, because as we modernize systems, we automate systems, and the computer systems, the sensors have to be calibrated, and all that needs to check so that it functions properly. Okay, so we're going to do a major refurbishment now on the S9 pump station. So we had an inspection done that really drove the refurbishment in 2016. Comes back and tells us, based on condition, that the pump itself is in bad shape and needs to be completely replaced with the impeller housing, shafting, everything. There's service bridge issues. So then further scoping, we're going to do a new service bridge, new trash rake system, new generators, and erosion control repairs that need to be done as well. So the engineering and construction group puts together a great design package and bids it out. We end up contracting with Harry Pepper and Associates for the refurbishment of this pump station. Like I said, it includes the bridge and the trash rake, new generator building, complete refurbishment of the 960 CFS pumps. It has retaining wall work, electrical panels, other work at S9A that we did. Total contract value just over $41 million. Simultaneously with this, the district itself, separate from the Harry Pepper contract, contracted directly with the original equipment manufacturer, local Caterpillar dealer, Pantropic, to overhaul and modernize the three main diesel engines in the station. Part of the modernization included a new computerized control fuel injection system, a new engine control panel that now includes emergency shutdown systems at the cost of about $2 million per engine. We also, at the same time, simultaneously worked with the Philadelphia Gear Company to modernize and overhaul the 3 gearboxes in the station. So that includes new bearings, new gears, new shafts, seals, painting, pumps, everything to make this like brand new again at the cost of about $1 million per gearbox. So the 41 with Harry Pepper and the combined engine and gearbox work, you're up to about $50 million plus for the major refurbishment of this facility. Now just kind of going, this is going to be that minor midlife refurbishment that I was speaking of that we do in-house with the use of contractors. So this is G370. It's the inflow pump station, one of the inflow pump stations for STA 34. It's a much more modern pump station than S9. You can see the automated trash rake was already included in the original design. Again, the fuel farm, the telemetry tower. You see the big main 3 exhaust silencers on the exterior of the building that support the engines. So the district acted as like the general contractor here in this case to overhaul the 3 main pumps in the station. So our millwrights and trade support group are going to do the removal and then the install of the pump once it's completed. We contracted again with the original equipment manufacturer Flowserve to do the actual refurbishment. This is reuse of all of the parts. This is reuse of the shaft, the impeller housing, the casing. It's just to redo everything and make it fresh again for another 20 plus years of operation. It's not replacement like we did at S9. So we did a little cost analysis here of the cost savings associated with the district acting as the general contractor. So not only did we do 370, but we did 372, which is the other inflow pump for STA 34. There's a total of 7. So in our estimates of acting as a general contractor for these 7 units, we saved approximately $4 million by doing this in-house. And now these units are ready for another 20 plus years of service. We also overhauled the engines in-house ourselves. So we have a whole fleet of Fairbanks Morris engines at 12 stations in the EAA. We have factory trained technicians in-house that can overhaul these engines from top to bottom. We overhauled the 3 engines at G370 in-house at around $420,000 in materials to do it. Had we taken the engine out of the station and let Fairbanks do it, or even brought their technicians in to overhaul the engine, it would have been well over $1 million per engine. Another part of the refurbishment of this station, again, we have engine control panels. The automation needs to be refreshed. It's electronics, it's a computer, just like your PC, just like your phone. We trade them in, we got to upgrade them. If we don't, the factory doesn't support them anymore. So in this case, the district acts like the engineer of record for the project. And we design and work with the original equipment manufacturer to refresh this. So we do the design work, review the submittals, do the inspections, and manage the project. So the cost from Fairbanks was about $1 million. Cost to do the design and oversight of the project's probably about 30% of the contract cost. So we're saving around $300,000, just a little over $300,000 for the project. So here you can see the comparison of the 2 types of scenarios that we do for pump station. The midlife minor that we can try to do in-house, or the major end-of-life one where we have to bring contractors in. It's really out of scope for the field station to be able to construct a bridge, put up a new building, and do all those facets of what a major refurbishment takes. And like we said before, there's 98 pump stations. They all have to go through these cycles at some point in their life cycle, from minors to majors to repairs, and all the preventative maintenance that goes with it. Now we have some new features and new types of projects that are coming our way that historically we have not managed, right? So now we have reservoirs. Reservoirs still have pump stations. They still have structures. They still have embankments. They still have canals. They all have to be maintained as previously described. But now we have some new challenges and new things that we have to do. This is kind of the cross section of the embankment on C44 reservoir. You have the seepage collection ditch or canal. You have an inspection tow road. You have a chimney drain collection system. So the chimney drains at midway through the embankment. There's a sand layer that actually collects seepage as it migrates through the embankment. And then the sand layer and the chimney drain collects that seepage and exits it through the embankment, because you do not want the entire embankment become saturated. It makes it unstable and increases the risk of a failure. So it's a major design component of the embankment. You have the crest road and the interior protection in the roller compacted concrete. We have our good old SCADA antenna here because we want it to be, this is an electric pump station that can be start and stop from West Palm. It can be monitored from West Palm. So like I said, we have our normal operation. I'm going to show you some new things that we have to do associated with reservoirs. We have to water now. We never had to water anything before. We let Mother Nature do all the watering previously. But because of the risk of a failure in the embankment, we need to keep this turf in great shape. So we need to water it on a regular basis during the dry season. And think about the C43 reservoir. It's 18 miles around it. That's a lot of water, and it's a lot of trips. It's a lot of manpower. We also have to protect these embankments more than we normally do from rutting and getting damaged. So we're even looking at some unique ways to do mowing, like robotic lightweight mowers that wouldn't damage the embankment. So now when we go out for mowing contracts, we also contract for the services for an agronomist who's going to do soil sampling for us. And we can do soil augmentations to keep the turf in really good shape, to prevent erosion. We also have to protect gopher tortoises, and we have to protect the embankment from gopher tortoises. So if we find gopher tortoise burrows, they need to be relocated. We also have to manage wildlife like feral hog populations, because they can do a lot of damage to turf and the embankment. They rut up the embankment and the grass in order to search for insects and grubs, and that's how they feed. Small grouping, 8, 10, 12 of them can do an extensive amount of damage in no time. So we contract with trappers to remove feral hogs. And then we have our STAs. So again, the STA has all the components that the other pieces of the system have: the pump stations, the culverts, the canals, the berms, all have to be maintained as previously described. Now the district has over 100,000 acres of STA treatment cells to manage. I'm going to have Leroy Rogers, he's the section administrator for vegetation management. He's going to come up and provide you some details on specialized maintenance that we do for the treatment cells. Thanks.
Thank you, Rich, and good afternoon, everybody. Yes, as Rich said, Leroy Rogers, I'm the administrator for the vegetation management section, and as most of you are aware, one of the district's flagship restoration efforts is the stormwater treatment area program. This involves constructed wetlands that are designed to remove excess nutrients from our surface waters. And as Rich said, we're managing a lot of this. We have over 100,000 acres of STAs and flow equalization basins for this water quality improvement. And vegetation is central to these systems and how they remove nutrients from our surface waters. A key concept here is that there are optimal plant communities that maximize STA performance, but plant communities aren't static. They're always in a state of flux. Disturbances such as storms and pest outbreaks, as well as natural succession, can all push these plant communities away from the optimal balance of emergent and submerged vegetation that these were designed to have. And when that happens, we start to see a decline in STA performance. So the vegetation management section that I lead, basically our mission is to keep these STAs in this sustained state of that optimal balance of vegetation, and it requires quite a bit of work. So one way that we maintain that balance is by actively planting desirable emergent species. Plants like giant bulrush and pickerel weed help slow the water, they reduce wave action, and in turn limit turbidity within the STA, and that's really helpful to a lot of our submerged aquatic vegetation. So we usually do these extensive plantings with contractors in large open water areas where we've lost emergent vegetation due to some sort of a disturbance, or in some cases in areas where that emergent vegetation did not naturally colonize. In other areas or other cases, plant community succession may actually lead to too much of a good thing. Over time, emergent vegetation, especially cattail, can become too dense and crowd out desirable submerged aquatic plants in these mixed marsh areas. In those cases, we will selectively control the emergent vegetation with herbicides approved for aquatic use to restore that mixed marsh condition. In the photos here, you can see areas that were originally dominated by submerged aquatic vegetation. Eventually, they were transitioned to cattail, and now due to our management efforts are again supporting these healthy SAV beds. At times, submerged vegetation may decline for other reasons. To address this, we will sometimes harvest SAV from healthy donor sites and redistribute it to areas where it's been lost. It's a pretty simple approach. We deposit this SAV biomass in the unvegetated area, and the plant fragments will spread around, root, and form new healthy SAV beds. And we found this to be a very cost-effective, low-risk intervention to maximize SAV cover in these STAs. So another persistent challenge we deal with in the STAs is invasive plant species. Floating plants like water hyacinth, water lettuce, and crested floating heart, shown here, can spread rapidly in Florida because they lack the natural controls that they co-evolved with. And so when they establish, they can quickly dominate the wetland and fundamentally change the ecology of an STA. There are a number of reasons why invasive plants need to be controlled in STAs. First, they reduce plant diversity, and with lower diversity, we have a less resilient system to environmental stressors. We've seen cases where the sudden loss of a dominant invasive plant like hydrilla has left the cell unvegetated for long periods of time, sometimes up to a year. So we're really trying to have a diverse set of species that kind of hedge our bets to the various environmental stressors that the STAs receive. Secondly, floating plants block sunlight, which shades out our desirable submerged vegetation and its associated periphyton. These plants also produce large amounts of fine organic litter known as flocculant, and when this builds up, it creates a very turbid environment, which again makes it very difficult for us to cultivate submerged aquatic vegetation. And finally, these effects can, in extreme cases, lead to lower dissolved oxygen, which can then lead to phosphorus release from the sediment back into the water column, which is exactly the opposite of what we're trying to do in the STAs. Floating vegetation mats are another management challenge in the STAs. When water levels get too high for too long, especially in emergent marshes, large mats of vegetation may break loose from the soil and form these floating tussocks. Once they detach, they rarely reattach. These tussocks drift and they damage other vegetation and increase turbidity. So we're testing tussock removal methods like the shredding equipment shown here, which we then follow behind with replanting to restore that stable marsh condition. Another persistent management challenge is the formation of preferential flow paths, or short circuits as we call them, which decrease the residence time of water flowing through the marsh. We want to maximize how long that water is in the marsh to get optimal uptake of nutrients. And when we do get these preferential flow paths, we will try to address those. Right now we're using semi-permeable marsh fencing to reduce the flow velocities in these short circuits and promote more even flow. We also use these in conjunction with our emergent planting to help protect those sensitive plants while they reestablish. And we're now taking a closer look at prescribed fire as a tool to maintain desired vegetation conditions in the STAs. As many know, fire can reduce excessive thatch or accumulation of biomass. It can reset succession and help maintain mixed marsh conditions. In other areas, fire may help regenerate declining emergent vegetation in, say, cattail marshes and slow the shift towards floating tussocks or woody species like Carolina willow. And we're now looking at an emerging tool that evaluating is drone-based ignition for prescribed fire. Drones will allow us in the STAs to ignite burns while reducing the need for airboats and other heavy equipment that can harm the marsh. And so this tool, something we're evaluating, basically the drones will drop small ignition spheres that react chemically just before release, and they create a controlled ignition point in the marsh. And it's real excited about this tool for using burns in the STAs. And that's everything I have for the STAs, Rich.
Thanks, Leroy. So we'll transition back to some more maintenance activities associated with the system. So we have a communications tower system. So we have 65 microwave communication towers within the district system to monitor and control the water management system. The map on the left shows the extent of the tower network. We have a centralized loop around the lake, Okeechobee, a southern loop that goes down into Miami-Dade, and then there's a spur up the Kissimmee River north to the north upper chain of lakes, and there's a spur to the west coast that the final tower is currently being finished up on. These 65, like I said, allow the water managers here at the headquarters to monitor and operate and keep a lot of efficiency in the system. These are their eyes and ears on the water management system for the water managers. These communication towers have a telemetry building at the base with all the electronics within that that operate that tower. They have preventative maintenance cycles that have to be conducted in order to keep that equipment in top shape. It also, like all electronics discussed before, go through obsolescence and replacement cycles as well. And as the system grows, that becomes more of a challenge to keep up with. So then, all of the water control structures and pumping stations and monitoring sites are managed by our SCADA group. They do design, development, installation, they do the maintenance, inspection, and preventative maintenance, everything for each of the individual sites. They call the individual sites that are deployed, the equipment deployed at the sites, they call it RTUs or remote telemetry units. There's almost 1,200 of them deployed. There's two different types. We have the Motorola systems, over 500, and that's for control. And when I mean control, they can open and close water control structures. They can start electric pumps, all from West Palm's headquarters. And then we have the Campbell Scientific, which are for monitoring sites, for stilling wells, for groundwater monitoring wells, and all the other things that are out there. All of these sites, almost 1,200 of them, have to go through preventative maintenance as well. The amount of preventative maintenance is done based on the site itself, agreements, mandates, the equipment itself, what it requires. There's a whole list of things here that get done every time they go out to check on the sites, from inspections and checking the batteries and the solar panels and calibrating sensors and such. And then you can see from these photos, some of these sites are very isolated in remote areas. They take airboats to get to, regular boats to get to. Some even our float helicopter has to be used to access these sites. So there's a lot of work. All of this as well goes through obsolescence. This equipment, these sensors, the the Motorola's themselves, the Campbell Scientifics, and on periodic basis, that all has to be upgraded and changed out as well. So before I go a little bit further, I just wanted to just briefly mention that the district has a huge fleet of equipment to do all of this work, right? We have over-the-road trucks, we have bulldozers, backhoes, we have cranes, we have watering trucks now, we have airboats. We have everything that we need to manage the system. It's over 1,000 pieces of either on the road or off a road equipment. All of the 8 field stations have fleet service equipment at each of the stations to maintain the equipment at their that's deployed and housed at their field station. It's a huge operation, and the guys are great at doing it. And we can turn vehicles around quickly and keep things mobilized. We can do repairs in the field when necessary, so things don't have to be brought back to the field station for repair. But they're just really good at what they do. So, all of this said, how do we manage, schedule, and prioritize all of this work that we do? So we have a structure inspection program where every 5 years, the water control structures and pump stations are inspection. We do a multi-engineering discipline inspection, including an underwater dive, to do this. And all of these inspections help the field station develop their annual plans and then prioritize the refurbishment of the system. And one of the biggest benefits of this inspection program is the reduction in emergency work. So we do the inspection. Each structure is assigned a condition rating from 1 to 5, 1 being no action required, that's probably something brand new, and then 5 being something that needs to be worked on within the next year. The big takeaway from this slide, I think, is this is like a 15-year period. So back in the 2011-2012 cycle, we were at 464 inspections to stay on our 5-year cycle. Last year, we had to do 720 inspections to stay up with our 5-year cycle. Our goal really through the inspection program and our maintenance thing is to not increase the C5s, which we've done a pretty good job at being able to do that, which is the ones that require immediate attention. But we have seen an uptick in our C4s, right? Ones that need to be done within 18 months or so. Really, I think that's just a reflection on the age of the system. I mean, the original system is at 50 to 75 years old at this point. So then we divvy up the work. Field stations take their things and work on it for the next year. And then the major stuff that has to go into capital gets forwarded to the engineering and construction group. We further analyze the projects by doing a risk assessment for each project. We kind of follow a American Society of Civil Engineers guideline, but we have our own matrix that we use. But what it is the likelihood of failure times the consequence of failure, which gives you a risk score for that repair or capital project that helps us rank all of these capital program projects. So we know we have a lot of stuff in dire need of replacement. Some common and major issues that we see that push us towards these refurbishment cycles was like the acid attack of those structures in the northern section based on water quality. We have a lot of undermining of wing walls and foundations due to erosion problems and whatnot. Corrosion of metals and pitting due to our environment. A lot of coastal stuff with brackish water and things that require that type of upgrade. Again, obsolescence is a huge piece because, you know, the factories and the components and different people do not support their older equipment, and you have to migrate towards newer equipment, especially in the electronic side of the house. And then, of course, issues associated with scouring due to high flow conditions and events and canal bank work that we have to do. I'm just going to highlight a quick 4 projects within the system that have been queued up for refurbishment work, kind of north to south through the system. This is the S65 structure on the Kissimmee River. It's really been a structure that's been influenced by the acid attack and the degradation of the concrete, and it's accelerated this within the splash zone, or the area within the structure that repeatedly is wet and dry and wet and dry. You see an exacerbation or acceleration of the acid attack in those locations. Due to the structure design, this may require us to do a full replacement of the structure in lieu of trying to repair the concrete in the structure. As you can see, it was placed into service in 1962, so it's as old as I am, and it's currently rated a C4. This is our S6 pump station in the EAA. This is the inflow pump station to STA2. The inspection found the pump to be in really rough shape and in need of refurbishment. The refurbishment of this pump would be very similar to the S9 pump, where the entire inside or rotating assembly of the pump needs to be replaced. The shafting, the impeller housing, and so on. When it's time to do the engines inside this pump station, they're the same as the S9 ones. They're going to have to go through that major refurbishment and upgrade for electronic fuel control. The gearboxes will have to be gone through, as well as auxiliary equipment that support the main engines and gearboxes within the facility. This is our S29 structure down in Miami-Dade. This structure is, through the inspection program, is being queued up for a refurbishment. You can see the service bridge with the exposed rebar, erosion issues, and degradation of the structure. But this is our poster child for resiliency, because this structure has been overtopped. The gates water has actually flowed backwards through the structure, over the structure during king tide events. So not only do we need to refurbish the structure, but we need to refurbish it for resiliency, right? So that means raising the service bridge, raising the gates, and doing a lot of stainless work and stuff to prevent further corrosion. And this station is also being queued up not only for that refurbishment, but a forward pumping station to supplement the capacity of the structure during high tide events and king tide events and whatnot. So placed into service 1954. And my last one example is the S332B and C pump stations. These were originally built as temporary pump stations to test out the idea of the modified water delivery program. They were successful. The district has kept these pump stations running since 2000, though they are temporary. This keeps our trade support group in the South very busy. The 332s as well as S356. There is an engine, a pump, a gearbox out of these stations every single year for refurbishment. They run continuously through the summer months. We had a major shutdown of these two stations within the last 2 years. There's long, large discharge pipes out the back of these stations that pump over to a retention area about 2,500 feet away. The pipes became deteriorated. They had to be removed. Okeechobee Field Station came in, did the pipe removal, basically built an above ground canal to channel the water from the pump station over to the retention area. So the replacement of this, is going to bring this thing up to standard electrically, mechanically, and structurally, and save us a lot of time and effort and trade support each year too, because of just how maintenance intensive it is to keep this thing these two stations, as well as the S356 station, in operation. So that kind of concludes my presentation on all the great work that the staff does. 2,100 miles of canal, 2,100 miles of levee, 98 pump stations, 930 plus water control structures. It's a massive system. It takes a large, massive effort to keep everything running, protect the citizens of South Florida, optimize all of the restoration program projects, and make it all happen. So with that, I take any questions.
Well, thanks very much, Rich, and thanks, Leroy. That was a really informative presentation. We're going to go to public comment now. That public comment will be directed to the board. Comments are going to be limited to 3 minutes. And Molly, I'll let you run that.
Thank you, Mr. Chairman. We do have public comment from Ben Olson. Mr. Olson, please unmute your mic.
Hey, can you guys hear me okay?
We hear you.
Alrighty. Well, good afternoon, governing board members. A little different on the learn side of this lunch and learn. By no surprise, I'm talking about WERP. On January 6th, the landowners south of Wingate Mill in the WERP footprint were able to sit down with staff to view the refined feeder canal basin water quality program modeling, the program that complements WERP and sets out to solve the problems created by WERP. The presentation was fantastic, but we also need to acknowledge the modeling staff water management has, as well as Chenmore and Associates, because that refined model is seemingly lining up with all the research I did on the feeder basin flow path history. I know we're getting to the point we're not too far from the true flow path. The model is seemingly showing where Kissimmee Billy Strand historically was, east of the privately owned land and south of Wingate Mill. As we discussed at that meeting, I and a few of my neighbors provided some further knowledge of where we knew culverts historically were and recommended a few changes. Stuff like locations where I'm pretty certain dynamite was used, which would skew the modern modeling, but nothing major though. Overall, the Feeder Canal Basin Water Quality Program, the solution to WERP's authorized plan, is shaping up to be true restoration without destruction. In no small part, this is because of the connecting canal that we've added back in that WERP started with. It's the canal between the Lard Can and the North Feeder STA, utilizing what is known as the McDaniel Ranch Southern Boundary Canal for part of the connection. We've come full circle over the past 10 years, but I am happy nonetheless to see the modeling seemingly working out for the most part. Just a few refinements are necessary. It is very apparent that WERP only works with the Feeder Canal Basin Water Quality Program, and the Water Quality Program will only work with the connecting canal from the Lard Can to the STA along the northern boundary of the Seminole Big Cypress Reservation. That was true in 2016, and it's true in 2026. If everyone in this project truly wants restoration, then that canal satisfies everyone's concerns. Throughout this process, it's appeared to me that water management staff have been stuck between a rock and a hard place, but somehow they are still pulling it off, so thank you all again. Very quickly, the only comment I would make otherwise, I kind of like this format of lunch and learn, and I had heard some years back there used to be more luncheons with the governing board members before monthly board meetings in which the public had the ability to just communicate with the board. I might have misheard that in person, or the person may have been incorrect. To be honest, I don't remember who said it. It was years ago when I heard it, but no matter the case, the ability for the public to communicate with the board in public, in person, for more than 3 minutes seems like it would go a long way to ensure proper restoration and transparency. That might be something we want to look into either bringing back or trying for the first time. I know it'd be a heck of a lot better if I could just speak to you all rather than figuring out how to squeeze everything into these few short minutes. But thank you very much, board members, for allowing public input and working with us, and I'm looking forward to seeing you all next month in person. Hope you all have a wonderful day. Thank you.
Thank you, Mr. Olson. Mr. Chairman, we have no additional raised hands.
Great. At this time, we're going to open the discussion up for members of the governing board. I'd like the record to show that Mr. Steinle did join us. I think Mr. Spotswood was on for a while too. I'm not sure if he still is. Please use the raise your hand feature and unmute yourself when I call your name. But I'm going to start off with my comments. First of all, I want to thank you for a really interesting presentation. And my takeaway from this whole presentation is no maintenance equals no flood control. So this is something that's imperative we do, and it's amazing what a big item it is. I don't know if you have this or not, but do you have a total cost of maintenance annually?
Yeah, I was just looking at that yesterday, Mr. Chair. This is Drew Bartlett. And it's hard to break apart because it
Yeah.
involves IT, it involves invoicing, it involves all kinds of parts of the organization. But if I were to sort of add it all up in my head and include land management itself and the capital O&M, I think we're close to like $800 to $900 million annually spent on making sure this flood control system works and using it.
Wow, that's a big number. Okay.
Yeah.
And I've got one question for Rich, and if you could explain this to me, it crossed my mind. It may have crossed other people's minds. When you're doing the refurbishment of some of these pump stations and structures, Are they totally inoperable, and how do you work around, because I know they need to function?
Yeah, I can answer that question. So
Thanks.
the control room requires us to be very conservative, and we do major refurbishments basically on each unit during the dry season. They usually give us a window from December through maybe the end of May to do a refurbishment on an engine, a pump, a gearbox, whatever it may be, and they only allow us to have one unit offline at any given time, so that we only impact the capacity by that, having that one unit down only during the dry season.
Thanks. That's helpful. Any other? I don't see any hands raised. Are there any governing board members who have questions?
Hey, Chauncey, I got to amend my number because I was doing the math in my head. I don't think it's close
don't
to
ever do
that. Yeah. So I think we are. I mean, I know the field station operations are right at about 450 million.
Okay.
And then that does not include our IT shop and other shops like that. So you just bump that up, a bit, and then you're probably closer to the mark.
So we're probably at $500 million,
Yeah.
plus or minus. Okay. I'm still not seeing raised hands. Any other governing board members?
Chauncey, I just put my hand up. It's Jay Steinley.
Just go ahead and talk. I can't see that. Thanks.
Sure. Sorry about that. No. I was just going to thank everybody for this. I think, listen, most of us have had the privilege of sitting on the board now for 7 years with some massive support from the governor, from the state legislature. So it's always helpful to sort of, rewind and understand where we came from and what we've done to bring this thing forward and generate progress on all fronts. And I think, as I sit in meetings and listen to this too, the clearest benefit of what we're doing is the visible benefit, right, to the ecosystem. But I always have to remind myself that, and it's also ecosystem related, that underneath the ground, all of us here are supported, and the growing population is supported and get their water from the aquifer. And so it's not just above ground what we're doing to protect and preserve, but it's below ground with regard to saltwater intrusion and everything else. And so I do this, and it's real estate, and it's health, and it's all these other things. But I have to go through this exercise to remind myself that, because the cost of what we're doing is so enormous, but so worthwhile when you think of it holistically like that. So I just wanted to say that. And then I think we always talk about this, and I appreciate the fact that so much time was given on O&M, on maintenance and operations, because I think Florida residents are very happy with the progress we've made on so many projects, and parallel to that progress will be the cost of maintaining and operating. So we don't just end when the projects end. This is an ongoing investment in our state, and it's always helpful to just sort of remind people of that. But thank you guys for doing this. This was really helpful for me to sort of recognize the progress that's been made in a relatively short period of time, given the scale of things.
Thanks, Mr. Steinley. Mr. Bergeron, you have your hand up.
Yes, thank you, Mr. Chair. What a great presentation, and I want to compliment our staff. This presentation really brings to the forefront of, the largest drainage district in the world, and on top of that, the largest environmental restoration ever attempted anywhere in the world. And we are so blessed to have such a great staff to be able to keep everybody safe, flood protection, water supply, and make sure we have a quality of life in the future by virtue of saving one of the natural wonders of the world. And it's a great honor for me to sit with all my fellow board members to be a part of making sure Florida can be an example to the rest of the world, that we can continue to have jobs and economical growth and a quality of life. A lot of people don't realize we live on a peninsula that's 400 or 500 miles long, and without the Everglades and the watershed, we'd have saltwater intrusion. That watershed replenishes the aquifer. So our mission, our goal is to continue to complete Everglades restoration. I want to thank our governor with his leadership and the legislators that has given us the opportunity to move at an extreme great pace on restoring the beautiful Everglades. And I also want to thank my fellow board members, wish them all a Happy New Year, and all of our stakeholders with good health and happiness and success and friendship, and spread the love. And I'm looking forward to a lot of progress this year. Thank you, Mr. Chairman.
Thank you, Mr. Bergeron. Colonel Roman, you're recognized.
Yes, thank you, Mr. Chair. First of all, thank you, Drew and Rich and Leroy, for setting up such a great presentation today. I think it's so important to focus on what it takes to maintain this system as this system continues to grow with all of our progress with Everglades restoration projects coming online every month, you know, several a year. Certainly we're climbing close to 85. So hats off to all of you for taking on this additional work and doing a great job in everyday operations and maintenance efforts across the board. I also want to highlight the fact that the talent and the skills of these folks that are repairing and maintaining a wide variety of engines, gates, electrical systems, computer systems. I mean, what we heard today was just amazing in terms of the number of skills and talents that's required. And to think that this team chooses to work for the South Florida Water Management District and take such pride in what they do is just phenomenal. So hats off to all of you, and keep up the great work.
Thanks, Colonel Roman. Well said. Is there any other governing board member like to speak? If not, I'd say thank you so much for joining us for today's Lunch and Learn, and thanks so much to the staff for pulling this together. It was incredibly helpful. Fortunately, a recording of today's meeting is going to be made available, so you can always refer back to it on the district's website. And that concludes today's Lunch and Learn, and we're adjourned.
Thank you, Mr. Chair.